На този интернет ще да пробвам да пиша майнер интернет банда.
То какво написано? Още ли е на Erlang?
Е.
58.
Беше най-другото.
Елен, какво стана? Не помогна ли?
Не, аз се оправих.
Добре, що случи на там това?
Защото чакай малко. Да. Само...
No stress, no progress.
Да, готово.
Почвам на английски направо, защото имаме много български как. Okay. Thank you all for joining us tonight for the 5th Blockchain Developers Meetup. If you don't know who I am, I'm Milan Radko, founder of Hack, a blockchain development company. And we also organize this meetup, which is monthly meetup for developers in the blockchain space. As always, we're gonna start with reviewing what happened lately in the blockchain space from a developer's perspective, and then we'll get into the topic for today, which is introduction to Polkadot. So, what happened recently? The list is short because I haven't had the time to research that much, but the main three things I got to share with you are these. Eternity blockchain is live. They launched today. Bitcoin Cash had hard forked, and Ethereum 2.0 is in the planning. So Eternity, for those of you who haven't heard about them, they've built a blockchain network that is giving us the opportunity to develop again smart contracts and decentralized applications, and they're providing us with some new cool features like state channels and built-in oracles, which are kind of needed here to be decentralized. And this is the Genesis block hash, which was tweeted by the founder, Yanni, this night. So more about them you can find, if you're not familiar, on their website, blog, forum, and whatever it is. The next thing is Bitcoin Cash hard fork. This was kind of not new thing because it was known since a month or two that is gonna happen. There was this release from BCH ABC. They released new version of their full node Bitcoin Cash implementation back in August, which included major software changes like transaction ordering and 2 new opcodes. And this proposal came after Craig Wright's blockchain development firm Nchain announced their own hard fork, Bitcoin Satoshi Vision, and they basically wanted to increase the block size from 32 megabytes to 128 megabytes, and to reinitiate the Satoshi opcodes and bring back the Satoshi Vision. They want to revert the implementation of the Bitcoin Core to version 0.1.0 to preserve long-term stability for Bitcoin Cash.
Wow.
Yeah. And the next thing is Ethereum 2.0, which was mentioned by Vitalik and his team on DevCon. They are preparing the proof of stake Casper, which we're gonna introduce us something called Beacon Chain. I'm gonna sit. Something called Beacon Chain, which is a central proof of stake chain, which has in its base a sharding system. So the Beacon Chain is gonna store and manage a set of active proof of stake validators, and this central beacon chain will also contain within itself shard chains and the count of them. So in the first phase, they announced that are primarily concerned with the construction, the validity and the consensus of the data of these shard chains. So basically it's still in development and there is nothing final yet. Also they announced there is a rough consensus that EWASM will be the execution engine. So they are planning to retire the EVM. One thing that they brought is like for a reason for this to happen is because it's easier to switch to EWASM, and there are already tooling available for us developers to start developing using EWASM. And the question here is, are they going to launch it parallel, or they're just gonna drop the EVM and start supporting only the EWASM? But we're gonna see it. So today's topic, introduction to Polkadot. For those of you that who doesn't know what Polkadot is, it's a project founded by Gavin Wood, who is co-founder of Ethereum. He's founder of Parity and part of Web3 Foundation. Polkadot is a relay mechanism that facilitates authenticated transactions from one blockchain to another and provides pooled security that is equal to all members, so regardless of the protocol they operate on, and also enables trust-free transactions between all its member chains. And interchain that acts as a pool of secured messaging between blockchains. They try to handle some stuff that you're gonna see just in a moment. So Polkadot project introduced us a lot of new terminology that is kind of familiar, but we haven't used to call this stuff this way. So they introduced parachains, which is a term for naming subchains, sub-blockchains. The parachains want to tap into the overall consensus of the Polkadot network, and instead of having to maintain their own consensus systems and mechanisms, they are tapping into the Polkadot network. Relay chain, this is the glue, the central Polkadot chain, which helps to coordinate between the parachains. And bridges. Bridges are a way to tap into the Polkadot network without the need to operate on its consensus. And for example, bridge can be, there might be a bridge over Ethereum network to Polkadot. So they are not giving up their consensus, but they are using the Polkadot infrastructure. So Polkadot, as it said here, is a network that connects blockchains, and they are attempting to solve problems like interoperability, scalability, shared security, and these are the three main ones. They allow new designs of blockchains to communicate and pool their security while still allowing them to have entirely arbitrary state transition functions. So how it is working? Polkadot is an interchain blockchain protocol. It's like internet messaging protocols like TCP/IP. It enforces order and the validity of messages between the chains. And this interoperability also allows the additional benefit of scalability by creating a general environment for multiple state machines. Who are the players in the Polkadot network? There are four main roles on the Polkadot network that its members might assume after staking their tokens, and that are validators, nominators, collators, and fishermen. So the validators are the ones that are securing the relay chain by staking dots. Dot, I forgot to mention, is the Polkadot's token, which is being staked. So validators are staking dots and validating proofs from collators and participating in the consensus, and they are the ones who secure the network and write to its history. The nominators are the one that can basically bond their tokens to validators and thus indicating trust. The collators, they maintain the parachains by collecting parachain transactions from users, and they bundle transactions from all parachains into the proof of validity blocks and then submit them unsealed to validators. They also monitor the network and prove bad behavior to validators. The fishermen, they are providing the security layer. They're the so-called network's police, and they try to weed out bad actors from the Polkadot network and get significant reward for doing this. So that was the theoretical part. I provided you with lots of research links and lots of other materials, but now we're gonna head over to a short workshop where we're gonna start our own Polkadot node using Docker. So if you are familiar with Polkadot, you probably know that their testnet has been up and running for a while, and their software is developed using Rust. Their node software is developed using Rust. There is a whole Medium blog post about it, explaining why Rust. Shortly, it's a very modern and fast programming language. So our goals for the workshop are running a node, and we're gonna check if it is shown on their telemetry server. We have a few requirements here. I'm the one, not only one, bringing laptop, but probably I'm the only one that is gonna make this. So we need a laptop, Docker, and Wi-Fi. You probably are gonna ask why Docker. In the early days of such projects like Polkadot, binary installers for Linux, for OS X, for Windows are usually not available, and the only way to start them is to build it yourself. But the process is very time consuming, although it's very well planned and very well documented. We're gonna Docker.
The security.
Yeah. If you're not trusting me, you're probably best to run it yourself, build it yourself, but also you're gonna wait a lot more. For the purpose of this demonstration, we're gonna use Docker.
So wait, are you gonna show running a Polkadot node or running a new substrate chain?
I'm gonna show you running a Polkadot node.
Okay.
I haven't had the time to
No, I
prepare
can show
myself.
you. I can show people a substrate chain.
Okay, great. Okay. So I'm gonna head over faster then. Okay, so Docker will help us solve two problems. Building Polkadot easily, and we'll try deploying the nodes in less than 1 minute, for example. Big thank you for Wilfred Kopp, which is the one guy from Polkadot that is maintaining these Docker containers. I haven't had the time to build Polkadot and create container myself, so I'm using his versions that are proven to be stable. And this thing here, Substrate, you're probably gonna ask what it is. It's basically a framework for creating cryptocurrencies, decentralized systems, and lots of other things in the blockchain technology. It's the most important part of Parity and Polkadot. And Polkadot is built with Substrate. So every project built with Substrate can run natively on Polkadot. And you can use Substrate to build new blockchain right away. So our first step is to I'm gonna walk you through the steps and then I'm gonna show you, because yeah, it will be easier. The first step is to pull the containers, and then we're gonna run the Polkadot container. There are a few steps, probably 4, for the whole workshop, but it's good to know what are these command lines doing. So Docker run, it's easy. It involves Docker and asks it to run a container. The --rm means everything related to the container will be deleted and cleaned once we kill the container. It's good for us to know that. -it will show us what's going on inside the container, and the other part is the name of the name and the version of the pre-built image that we want to use. So we are going to use 0.2.17, which is the most stable version till now. They have some new builds, but I haven't tested them yet, so if you are adventurous, you might try with latest version. And one of the last steps is to create a directory where we're gonna store our blockchain information. The whole blocks are gonna be stored there, and run the container and open the port. So if we want to run it with a name that is kind of familiar with us, and we want to customize it, we can add the flag --name at the end and add the name of the Polkadot node that we're gonna run. Yeah, and lastly, we're gonna check if our node is shown on the telemetry Polkadot.io, which is a dashboard for monitoring the current active nodes. There are also explorers where we can poke around, create accounts, and there are also cool stuff like vanity account creator, vanity address creator. You can create basically address for yourself with some word included that you want. So I'm switching now for the just a sec. Okay. We'll need terminal for this purpose. And these are the steps that I've shown you. I've already pulled the Docker container, but I'm gonna show you what will happen if I try to pull it again. Oh, okay. I haven't run Docker yet. Okay. Okay. So is my Docker daemon running already? running. I'm gonna wait a bit. I should have prepared myself, but I'm not. I don't see it here, but it is probably somewhere around here. Okay, it's running now. So, pulling the container. Okay, we receive a notification that our image is up to date. The second thing is to pull the substrate image. Yeah, it's up to date also. The next step is to run the Polkadot container. And by running it, we see that a new node is initiated with the name Orange Trucks dash 8298. So it's syncing now and starts to sync blocks. Okay, so we're gonna stop it and start it with our own name.
You can actually zoom the result.
Okay. Okay.
Ctrl plus.
Yeah, but this is item 2. Just wait a bit. There is on this setting here. Cool.
Yeah, check here if there is. Check it.
Yeah.
Okay, so okay. Yep. Okay. Is it better? Okay. So now we're gonna run our node with the name hack.bg without the dot. Dot here is a forbidden symbol. So this is the testnet Kumelanki, and we see that it's starting to synchronize. The target block is around 2.5 million, and we are still on a bit after 500,000 block. So we're gonna try to see if our node shows up on the telemetry.polkadot.io, which is a website showing the active nodes. Okay, so we're gonna scroll down, and here we are. So our node is up and running. Yeah, there are also lots of other nodes popping up. So another thing that we can check is the one thing that I provided here in the presentation. This is the Polkadot Explorer and UI. Okay. Our WebSocket is unreachable. This is probably because of the network change, but this is the one thing that you want to, if you want to poke around with your own node, you gotta use this thing, this JavaScript version that is poking your local node. And if you want to access the current testnet, this is the URL and the access point to do that. Also, I was gonna show you how the staking mechanism works, but I haven't had the time to sync the whole network. But okay. Okay. So here we can see the block explorer, and we can see the current block and the current era. Also the time that passed since the last block. And here if we tap on some block, we can see the info stored inside it. Here on the left side we can use the options for transfer, stake, and participate in the voting. But I am experiencing some luck. So this is our account, or my account for now. Here we can use it for transferring of dots of value, and if we have a recipient, we can send something. In the account section, we can create a new account. This is our seed, and we should be keeping it safe. So we can name our new account, and we can encrypt it with a password. And also we can have addresses that we are working like an address book. Also we can look over the chain state, and this is some cool thing, vanity address creator, which I hope to show you. Okay.
Положили вид?
Nope.
Very good, now you have stopped.
So I hope it's only the network connection.
Maybe.
Ah, okay.
No technological issues.
Okay, do we wait? We're gonna check
Technology made my
what's
life
happening
worse.
in our node. So here you see that we are syncing with the network, and it's gonna take lots of time. And I'm getting lots of timeouts.
Just
Yeah, not,
moving.
not going to sync anytime soon.
Yeah.
I don't see any changes in the code.
Here.
No, in the
No,
Polkadot.
In
Wait.
the console, the best stays the same.
No, he's just scrolled.
Yeah,
but it still
stays
stays
the
the same
same.
number. though.
I am receiving lots of timeouts.
Important.
Probably I'm gonna try switch the network.
No, but we're not going to
Oh,
sync.
you're on the free, we're on the members.
Okay.
We're not going to sync to the network
Yeah,
anyway,
but
so-
yeah,
Ah.
we're not gonna sing, but
Well, I'm advancing, but I'm like 1 million blocks behind.
okay.
But you're 2 million
No,
blocks
but we
behind.
then anyway, change this is the lobby free, it's nothing, change to the members.
Okay.
Ah, sorry.
To show you that the blocks are moving. Okay.
Wow.
Yeah, my blocks are moving.
Okay. Cool.
But I'm on my phone.
Oh
okay.
wow.
So we get lots of.
No,
Yeah.
no,
Now
no.
they move. Okay, and now we see that here also things are changing, and we are receiving the new blocks. like, I don't know, 50 or 100 blocks per some seconds. So there is this IPFS, it's some enthusiast store the whole blockchain to the 2.5 like million blocks
So you
on
can see.
IPFS, but I experienced some technical issues today and again haven't had the chance to download it. So yeah, basically that was what I was supposed to show you. If you're interested, you can poke around Polkadot. They have lots of resources and very helpful community. I've provided here some resources and I will show you and give you the presentation and links and everything else. They also have a Riot channel and they're also active in GitHub and it's easy for you if you want to poke around to get in touch with them and get help if needed.
Is your presentation going to be available on the video?
Yeah. I'm gonna upload it
Okay.
right away.
Alright, cool, thanks.
So if you have any questions, I'm not that technical into Polkadot, but I will try to answer it. Anyone needs.
It's pure proof of stake.
Yeah, it's proof of stake. I was gonna show you the voting and staking mechanism, but again, we're gonna be for that we need to have a synced node because we're gonna lose our.
So the nomination, that sounds a little bit like DPoS, does it?
No,
No, it's
absolutely no.
not.
That's exactly why they decided to call it nomination and not delegation, because the same mechanism is called delegation in Cosmos. But what it really is like, so for example, DPoS is just a round robin of like predetermined validators which are
Right.
like voted upon through delegation, right?
Yeah.
And in Polkadot, I actually think calling it proof of stake is really wrong because
Okay.
like it does have proof of stake, but what you usually call proof of stake is stuff like Next, Peercoin, and just stuff like from like 5 years ago.
Okay.
The initial proof of stake stuff.
Okay, but
So-
you have validators, a set of validators. How they reach consensus?
No, wait a second. So the consensus algorithm is called Grandpa,
Okay.
and it's hybrid between overrun and PBFT.
Okay.
So it's really PBFT consensus. But like the issue with PBFT consensus is that you have to have a predetermined validator set, and it's usually used for permission systems because you don't have a like permissionless way of determining the validators like in Bitcoin and like in Nakamoto consensus, where anyone can just participate at any point. You have to have a validator set predetermined.
Okay.
So the way they solve that is actually they add staking on top of that in order to facilitate CBO resistance, in order to like keep the validator set up to date.
Okay.
You know what I mean?
Yeah.
So
I do.
it's like PBFT plus proof of stake on top. So
Okay.
the way it actually reaches consensus is PBFT, but the way the validator set is determined is active POS, and the delegation actually is just a mechanism where, like if you are a user and you have a small amount of tokens, you can delegate them to a validator so that you get like part of what they earn, and they get their voting power increased. But if they get slashed, you get slashed as well. So that's the difference. It's not like in EOS where you vote once and you determine the validator set. It's an ongoing process where you have a danger at any moment of being slashed.
Gotcha. Okay.
Thank you for the explanation. Yeah, so I'm finishing up and I'll give the stage to Ivo to show us the substrate part of Polkadot. Имаш ли HDMI? Okay.
Great.
So it's nominated proof of stake.
Well, Cosmos, I actually think that Cosmos is the first team that actually like described the entire thing, and they call it BDSM for bonded delegation, staking, and Merkle.
Yeah.
Wow.
Where the Merkle actually references the light client capability, because that's actually a really important thing. The built-in light client capability in Cosmos and Polkadot is actually what allows the interoperability plus the fast finality consensus. So, because you have a light client functionality, the validators from one chain can very easily monitor another chain. And they can very easily monitor a lot of chains because of the light client capability. Otherwise, you have to download the whole blockchain in order to know what's going on. And yeah, the fast finality is needed because like proof of work can reorganize, and you don't want that if you have interoperability. If you already count something as being done on one chain and the other chain reverts, you can't have that. So that's why you need instant finality consensus. Alright, so well, that's a bit small, but I
They
guess
always say that.
yeah, you know, that's what she said. But I guess I can work with that.
I'm not sure what is the use case of Polkadot.
There's like many
great.
use cases.
You can transfer not only value between chains, you can transfer
Messages.
data, and it is a bridge between chains.
The biggest use case that they're actually selling is the interoperability. So like any chain can communicate with any other chain, including Bitcoin to Ethereum, although you can do that with atomic swaps, but you can do it like autonomously with Polkadot. So like for example, in Bitcoin, if I want to trade like one Bitcoin for a number of Ether with you, we can do that with an atomic swap. But if I want to do it like send Bitcoin to a smart contract on Ethereum, I can't do that.
So the idea is I need to stake some Polkadot. I need the dot. Isn't that a step a little bit thick? No.
No. If you want to interoperate, you don't really need you need the dot only if you want to be a validator.
Yeah.
Oh wow.
The dot is only for the validators, and they said that there are gonna be like 10 million dots.
Do they stake the validator? Have to stake the dot so to prove that it's not going to curse the network or what?
Yeah, the validators actually stake the dots. And like in early proof of stake, you have this issue of long range attacks. And the way they actually solve it is with bonding periods. So if you're a validator, even if you have staked, then you cannot unbond your stake for a certain amount of time.
It's blocked, time.
Yeah.
So you got era, right?
Huh?
That was era.
The era. But maybe it's before the era starts and then after you can...
No, the eras are a Polkadot specific concept. It doesn't have like anything to do with it. It's just like you cannot unbond for certain number of eras, or like in Cosmos it would be a certain amount of blocks or whatever. I mean, it's just a certain amount of time. But it's like hard coded in the network. I'm not sure what it is exactly. It's like maybe a few months. So my Polkadot node is natively installed. It's compiled from source code, and so what happens here is that I cannot connect to the telemetry server. It's a really weird error, but I know what it is, so no telemetry. And I'm at block like 1 million and something, and I was hoping to show you like a bit of sync as Milen did, but my blocks are actually syncing quicker, or at least were before I stopped it. We'll see. I have like 24 years already, so it should start pretty quickly. And then I'm going to show you like maybe a bit of context about me first of all. I'm the founder of ADEX, which is a protocol for trust minimized advertising. And the reason we're looking into Polkadot is like because of the interoperability, scalability implications, and etc. And the reason I'm telling you this is that because I'm going to show you our not implementation but boilerplate for implementing on Polkadot. Nothing has been actually written yet, but I have it here, and I'm not going to be able to replicate the Gavin demo because I cannot install the UI, because you know this Node.js npm security issue that came up in the last few days. They unpublished some modules from npm, so now I cannot bootstrap the UI.
Maybe for good.
Yeah, so like this is an example. If I do substrate, UI new and let's say Alex protocol, it's going to try, and then it's going to end up with saying some modules are not installed. But let's try it just in case. In case they republish the modules.
Developer never give up.
Yeah. Yeah, it's worth a try. Actually, that looks kind of.
It passed already critical point.
You
so-
only know where it's gonna fail.
No, it's usually failing at the end. So yeah. Okay, so flat map stream does the module with the malware. So yeah, not
Okay.
gonna happen. I don't have a local instance of that, so fuck it. But yeah, I'm going to walk you through the source or something. So as you can see, it's syncing or not.
It was.
Yeah, it's stuck now.
Yeah.
But we didn't start at that block. We started at a different block. And now we are at a later block, so it's kind of syncing. So yeah. And this is a directory with a new Substrate project. And Substrate is a framework for building blockchains. And the cool thing about it is that it provides all the primitives for building a new chain. Like peer-to-peer networking, consensus, actually provides pluggable consensus, so you can even do it with a Nakamoto consensus like Bitcoin. And it really provides a lot of the primitives you need to build a new blockchain. So, like when in the past doing your own blockchain would be stupid, because you would be allowing all of those security issues, in Substrate you only write top-level logic. You don't need to write consensus, you don't need to write networking, you only write what actually happens. Like if you try to transfer a coin from party A to party B, subtract the balance of party A and give balance to party B. So yeah.
So just the state transitions basically. You're
Yeah,
defining-
exactly. And
So, but
yeah.
if I wanted to do a different protocol, would that allow?
different consensus mechanism, you mean?
Not necessarily. Like if I want to, let's say, define my own system for picking up the validators, or
Yeah. So that's also part of the so-called runtime. And another cool thing to say is that the runtime is just a piece of WebAssembly code.
okay,
So it's absolutely portable and it's absolutely like isolated and also deterministic, but that's another topic.
Okay.
And it has a function called, I think it was, I'm going to show it, but it was something like get authorities.
okay,
So it is your job as someone who implements the runtime to actually define who the authorities are. And authorities doesn't like mean absolute authorities like in proof of authority,
Right.
but it means just like who are the valid parties who can sign the block.
okay,
That's about it.
okay. Because this is very interesting to me because we could actually prototype some of those. I think we actually solved that problem with not using proof of stake for these validators. So we figured
It
out.
doesn't matter what you use. I mean, you can code it on Substrate.
That's good.
Yeah, and also the transactions are not. They're actually not called transactions. They're called extristics, and the reason is that. Like it's an abstraction over transactions, where a transaction is something that the person does, and an extristic is something that the blockchain takes for granted. Like for example, the time.
Okay.
When you validate actually construct a block, you are actually inserting the time if you're Bitcoin or if you're Ethereum, and that's called an extristic in Polkadot. So like the block is a function, and it's an abstract deterministic function of all the extristics. So the extristic is just a binary block. You can parse it in any way. It could be JSON, could be like whatever, Ethereum, like I don't know how the binary format is called in Ethereum, but whatever. So this is like excluding the target. This is basically all of the Rust files that you need to bootstrap a new Substrate chain. And why Rust? They do have a blog post explaining this, but it's like, someone on Twitter defined it as if you are in a candy store and you get to pick all of your favorite candies, and that's basically Rust to all of the other languages because it combines like a lot of stuff from. It has zero cost abstractions like C++. You can write really high level code like in JavaScript, but it really compiles like really efficiently. It also has really strict type checking and some algebraic data types like in Haskell or in functional programming. So it really combines like the best of all languages. I'm hoping the downside to this is that it's really hard and compiles really slowly. So I'm hoping to show some of the cool things about Rust in this source code, but I doubt it will happen. It's pretty ugly. But yeah, this is all you need to build a new like substrate chain, and there is a nice tool to actually bootstrap. It's called substrate node new, and you can download it somewhere from GitHub. I'm not sure, but it's basically a bash script. It's nothing more. So you don't have to worry about downloading binaries. It just gets the template, rebrands the template, and stuff like that. So the main file would be main.rs. That's just some boilerplate. Get substrate defines the main function, version, commit, executable name, alter, description, nothing interesting. The first interesting file would be chain spec. This file defines the entire chain specification as the name says. And this is just like a struct that defines all the initial balances.
Okay.
And this is the runtime. This is where it reads the runtime, and I'll show you the source code of the runtime in a bit. But this is the actual entry point to the actual substrate node. That's basically the genesis state. It initializes a timestamp, the consensus mechanism, which is also defined as like look, that's the thing you were asking about the authorities.
Yes. But see, what I'm interested in a mechanism where I can
that's in the runtime.
I
I'll show
can
you.
design at runtime how these authorities change.
Exactly. That's exactly what the runtime does.
Alright.
I'll show you in a bit. So the upgrade key is like a way to upgrade the chain on the fly. Since everything is WebAssembly blob, there is like if the validators all agree to upgrade, there is no need to upgrade the actual software that the validators are running. You just need to upgrade the WebAssembly source code, and it's compiled on the fly. So nothing else is interesting here. Maybe the balances, which describe stuff as a transaction fee. Yeah, pretty much. Cool. Oh yeah, I went through that, and now the runtime. So this is practically all you need to build a runtime, and the cool thing is that because Rust is such a powerful language, you can build it to WebAssembly, and you can build it without the Rust standard library. As you can see here, this is a compiler macro which has no standard library. This drops stuff like threads and like operating system dependent stuff which you cannot really have in WebAssembly, or in this instance anyway. So you require some stuff from the substrate like libraries, and most of this is boilerplate. But the cool thing is that it defines types. So the way substrate works is it leans on the generic type system of Rust, where you can do a lot of generic programming, and you basically define your entire runtime as a generic trait of all of these types. So you can change those types anytime you want. So like if you decide that the account ID would use like not an elliptic curve 255, public key it would use something else, you can just change that, and that's it. So it makes it really easy to change stuff like the underlying crypto primitives and like the hash, or if you decide that uint64 is not enough for your block number, you can change that as well. That's more type definitions, and it's kind of readable. Like you can see that the header type is a generic header but instantiated with a block number, which we already know is a uint69. Blake to be hash is the secure hashing function. That's the jest item of a hash, which is like also 2, 5, or 6-bit hash. So I guess most of those is type definitions. And if you need to define your own module, the Substrate runtime is built out of modules, and all of the built-in modules are part of the SRML, which is like the Substrate runtime something library. So balances is like part of the SRML. So if you want to do stuff like just changing balances for users, you use the standard balances module and you don't write your own. And if you want to define your own custom one, you add it here in constructor runtime, and in that case this is addX, which is added right here. And you have more boilerplate type definitions and etc. And this is the actual module that I'm gonna be writing. Yeah, never mind that. So this is really simple right here. This is basically what you need to define your own logic on the chain. All it does is includes the codec. I'm actually not really sure if I need that. The SRML, which is, as I told, kind of the standard library in the runtime. And I get storage values so that I can read and write to the storage. So that's a really cool thing. Substrate also provides me with storage. And then I define my own struct, which is basically specific to my own module in the chain. And as you can see, it's a generic, so it gets the same type as the entire chain uses for an account ID and a balance, and I build from those. This is basically a payment channel, to give you a little bit of the context. It has a creator, a deposit, a valid until date, a vector of account IDs, which is the validators for that specific payment channel, and a specification which is just an arbitrary like vector of bytes. And then you move on to you basically what you need to do in order to do your own module, you need to write that. And this is a compile and macro in Rust. And then you just have this little bit of boilerplate here, and then you define your own functions. Every function has arguments. The first one always has to be the origin, which is like who is invoking the function, and it always has to return a result. Everything else, it's up to you. So yeah, in this case, it ensures the origin has actually signed the transaction, prints out the channel, and basically does nothing, but in reality what I have to do is use the balances module to decrease the free balance of the sender in order to lock in that amount of money as a channel deposit, and then on withdraw I need to kind of do the opposite, like increase free balance. So that's pretty much it. And it looks a lot like writing smart contracts in Solidity, except it's in kind of more developed language. And when you have the UI running, the UI automatically updates depending on your functions. Your functions always, like in the JavaScript, you can always see the latest functions. For example, if I change that and compile, it will automatically show up in JavaScript, which is really cool. And basically, it's done through the macro. The macro, other than generating Rust code to actually compile this, also generates metadata in the form of JSON. Sends that to the UI knows what it's doing, so you can invoke any of those functions in the UI directly. And let's just compile it and run it, and it's unfortunate that I don't have the UI, but yeah, this compiled immediately because I haven't made any changes to the code. But yeah, and that's it. That's basically a new Substrate node. Yeah, question?
I have questions.
Yeah.
So I don't understand the demand for dot. For the dot token.
For the token.
Yeah, when
Right.
when do you need a token? If I'm gonna send the transaction to Ethereum and to Bitcoin, and I do not need to buy the token to make
No.
the transaction.
No.
So where does the token take the value?
Only for like securing the Polkadot network itself,
Mm-hmm.
and only for the validators. And if you want to send like tokens within the Polkadot ecosystem.
But then why does the token have value? Because if the validators have to stake the token,
Yeah.
but they have to take the transactions and send them to both blockchains.
Right.
So why does the token have value? Because they will not.
No, get your point. Like it's only within the ecosystem and it doesn't have value outside of it. Is that what you mean?
Uh-huh. Yeah. So
Yeah.
that's,
Yeah. Okay.
so there is no demand for dots.
No. The thing is, a complex project like this is really hard to like sell it. And what they have focused on is the interoperability. But in reality, it could be like seen as an alternative to Ethereum, although it could be interoperable with Ethereum. The thing is, it's so much easier, like for me, if I want to develop my own logic on top of a blockchain. It's so easier for me to do it on Substrate and on Polkadot. So in that way, it's competing Ethereum. So what I'm trying to say is that it has a mainnet which is functional on its own. The interoperability it's kind of a side effect, really. But this is also a thing that Cosmos did. Like in order to have a successful ICO, they focused on the thing that makes them like most hot. But it's really a lot more.
Do you need dots to make your own token?
No.
You don't have to
No.
mint, stake, or anything?
No. Like if you build your own zone,
Okay.
zone is the term in Cosmos. If you build your own parachain, all you need is like what I showed you. You know, just to code your own module or something.
Okay.
You don't really need you don't really need the dot token. Although the validators who are staking the dot token are going to validate your parachain. Because the way it works is that the relay chain has, let's say, like 500 validators or something like that. It will be thousands, but it doesn't matter. And those validators are rotating between who gets to validate which parachain.
Okay.
So your parachain would be secured by those validators, but you don't need any specific token economics on your own.
Okay.
Although,
So you don't pay them, and they don't
although
earn any money.
that's the although. Although it would be smart for you to actually provide an incentive mechanism to the validators.
Yeah.
Because if one day there is too much competition for parachains, for which parachain gets validated, then it would be a competition of
Also,
incentivization.
what is the incentive of being a validator? I mean, now I'm a
Oh,
believer.
you're getting like transaction fees. So
Ah, okay.
yeah,
Okay.
the same like in Bitcoin.
Okay.
These parachains have their own consensus mechanism.
No, the collators are responsible for actually producing the blocks, and then the consensus on the relay chain would rotate the validators on the relay chain between the parachains. So like if the relay chain has 1,000 validators, then 10 validators are going to be delegated to your chain every round. Actually more, like 30 or something like that.
And the consensus is the same that all the
The relay
parachains
chain.
have the same concession mechanism as the relay chain.
They plug into the consensus
Yeah,
of the
they're
relay
using
chain.
the Polkadot pool consensus. If you're using your own blockchain, you can use the bridge and not use the Polkadot pool consensus.
Yeah, but the thing is, the limitation about this is that because there is a limited number of validators, there is also a limited number of parachains. So the way this is solved is like a parachain could be also a relay chain. So there could be a hub and spoke model where there is one relay chain, and then a parachain of this relay chain is a relay chain itself to other parachains. So it's like a snowflake. Yeah.
So the benefit of doing something with Polkadot, if I can resume, say it shorter, is that you can build something on top of something that is already. I mean, first it's easy to. It's easy to build your node, and
Yeah.
it's easy to, as you can see, this substrate.
Easy
so-
and secure, that's a really hard, a really important thing, because usually if you build your own chain, you open yourself to all kinds of vulnerabilities.
Yeah, and then it's easy to personalize, which means
Yeah.
to put your own logic on top of it.
Exactly, yeah. And the thing is that, for example, if you build on Ethereum, you have this limitation of like always requiring gas to stuff, which is something that you avoid altogether on Substrate.
Yeah.
And also the pure scalability, like you have so much more on Substrate, but that's, let's say this doesn't matter.
How do they manage the spam of the network?
The what?
Spam.
Oh yeah, so like in any network you have a transaction fee.
Okay.
I mean, you do
Yeah,
have
you just mentioned. Yeah.
in your own chain you can define your own transaction fees. What I'm trying to say is that you're not forced into using a network-wide token.
Mm-hmm.
So, like for example, if a dApp has its own token, it doesn't also need Ethereum in order to work.
Yeah. I see. Wow, cool.
So the demand for DOT.
So that is dot going to go up or dot is going to go down?
When moon.
When moon?
Well, yeah, I guess like you can defend it with the like regular proof of stake arguments, where a token is a staking token, but it also pays transaction fees, so you have an incentive, like because it's kind of a dividend token, you have an incentive to actually buy it. Pretty much, I mean, it doesn't get more detailed than that.
And the relay chains need DOT.
The relay chains need dot, yeah. The parachains don't.
The parachains don't, but the relay chains do.
Yeah.
And the parachains can use any other thing.
Yes.
Yeah.
Okay.
Okay. Well, if you want, we can wrap it up and then get a beer and continue chatting about it.
Cool.
So thank you again, Ivo. And
He says, done? Okay.